Good evening and welcome back. We are going to be dividing section 8.2 into two sections. We're going to be looking at solving absolute value equations and absolute value inequalities. So solving absolute value equations is going to be a little bit of a twist, where the twist comes in the first step. We're going to use that same twist when we solve inequalities and then apply the techniques that we learned in 8.14 inequalities to solve absolute value inequalities. So we're going to go ahead and take a look at showing how we solve very simple ones. So we're going to take a look now at question 21 in what exactly is an absolute value. So an absolute value is something you can put out is these two lines here. So these two lines here is basically what makes up an absolute value. And you can take anything inside of this, and whatever you put in, whether it's positive or negative, it's going to make it positive. So what the absolute value is really the distance on a number line. Any number is from 0. So if you have, let's say, 7, well, 7 is going to be 7 units away from 0. If you have negative 7 on a number line, that will also be 7 units away from 0. So just drawing kind of a just generic number line here, where we have 0, where we have negative 7, and we have positive 7. If you were to count these up, this would be 1, 2, 3, 4, 5, 6, 7 units away from 0. This would be, and I apologize for my units not being precise here, but the number 7 would be 7 units away from 0. So an absolute value essentially determines the distance any number is away from the center or 0 on a number line. So if we want to solve the possible values of x that will generate a 7 on the outside, we do something very simple here. We're going to split this up into two parts, and we're going to write the absolute value of x being equal to positive 7, and then the absolute value of x being equal to the value of negative 7, which doesn't seem terribly difficult. So as a concept, it's not terribly bad. But this technique of splitting this up into two parts, where we take the positive and we take the negative of what's over here, is going to be an important technique in helping us to solve some multi-step equations. So let's take a look at a few examples of this. And let's take a look now at 27. So I've got the equation 2x, or the absolute value of 2x minus 3 is equal to 4. So what I'm going to do now is, if I want to solve the possible values of x that are going to get a 4 for me, I need to know what value of x is going to make this 4 on the inside, and what values of x are going to make this negative 4 on the inside. So, tell you what, just thinking, let me hold off on this question for a moment here, because I think the math is probably going to be a little complicated. Let me start you off with 31 first. This one probably isn't going to be so bad. So I'm going to take the absolute value of x minus 2, and that's going to equal 6. So you may look into this and say, well, let's see, what minus 2 equals 6? And you say, well, that would be 8. 8 minus 2 equals 6, so 8 should be a solution for x. But we also want to see what value of x we can put into this so that we get a negative 6 on the inside, because we know the absolute value of negative 6 is equal to 6. So if I let this be equal to negative 4, well, negative 4 minus 2, that should also give us negative 6. So this wasn't so bad, and you might be able to generate those on your own, but let's see if we can develop a simpler technique that can help us calculate this regardless of the size of the numbers or the difficulty of the equations that we're working with. And this technique will follow like we did in the previous question from over here. So I'm going to take the absolute value here, and I'm going to split it up into two equations. I'll write this as x minus 2 is equal to 6, and x minus 2 is equal to negative 6. So I remove the absolute value from x minus 2, and then I write the 6 here as positive and the 6 here as negative. So here I want to see what value of x will generate a value of 6 here, and then what value of x here will generate a value of negative 6 on the inside. So here I'm just going to go ahead and add 2 to both sides. And as we discussed, yes, 8 minus 2 will give us 6. That's pretty straightforward. Here I'm going to add 2 to both sides. And that's going to be x is equal to negative 4, as we also discussed. So for this now, we have 2 solutions to this absolute value equation that's going to help us generate this answer. And we now have the solution for that. Hopefully this wasn't terribly difficult, but we're going to continue applying this technique to questions that may be a tad more rigorous. So let's go ahead and do this one now. I'm going to go ahead and split this up into 2 parts. It's going to be 2x minus 3 equals positive 4, and then 2x minus 3 equals negative 4. And we're going to solve each equation now. So I'm going to add 3 to both sides. That's going to be 2x is equal to 7. Then I'll divide by 2 and get x is equal to 7 over 2. We are in Math 95. You may leave your answer in that form. There is no problem with that. Let's take a look at the other solution now. So we're going to add 3 to both sides, where we have 2x is equal to negative 1. And if I divide by 2, I have x is equal to negative 1 over 2. So I have 2 solutions to this now. So you can express the solutions like this. We can also express this as a set of numbers, which you probably find this on your keyboard. I believe it's located just to the right of P. It's in uppercase. You can write your solutions as negative 4, 8. This is not a parenthesis. This is basically used to denote a set of numbers that make the equation true. And then over here, I can write this as negative 1/2 and then 7 over 2. You'll note that in both instances, I've listed the negative numbers to the right and then positive numbers to the left. In a set notation, it's usually proper form to always list the lowest number first and then list the numbers in order from least to greatest, which is what I've done in both of these sets. So I myself would accept both these answers, but you should be comfortable with expressing your answers in this way or in set notation also. Let's continue. So let's take a look at another problem. This is going to be problem number 37. So 37 is going to read the absolute value of 5x minus 3 equals 37. So you'll notice that in this question, think about what makes this different. If you want to stop the video to contemplate that, you may. Or if you want to just kind of jump to this. What makes this one different is that the absolute value is not by itself. Until we get the absolute value by itself, we cannot split this into 2 equations. So what I'm going to do is whatever else is with the absolute value, I'm going to go ahead and get rid of or make 0. So I'm going to reduce that and get the absolute value of 5x equal to 37 plus 3, which is 40. So now that I have the absolute value of 5x is equal to 40, I can now go ahead and split this up, where I can write this as 5x is equal to 40, and then 5x is equal to negative 40. And I solve these like the other problems I did. I'm going to divide both sides by 5, where I get x is equal to 8. I'm going to divide this by 5, where I get x is equal to negative 8. So I have these 2 solutions here. Again, I can also express these in set notation, basically where negative 8 and 8 represent the set of numbers that represent the solution to the following absolute value equation. Let's take a look at another question that could be a little tricky for you also. This will be question 39. This is going to be 7 times the absolute value of q minus 2 is equal to 9. So what am I going to do first? I need to get this absolute value of q by itself. So I will simply first add 2 to both sides, where I'm going to get 7 times the absolute value of q is equal to 11. And if you see where this is going, you're going to recognize that this answer is not going to be real pretty. It'll be a fraction. That's okay. So I had to add 2 to both sides. I now need to divide both sides by 7 next. So I will go ahead and do that, and when I do so, that gives me the absolute value of q is equal to 11 over 7. At least the nice thing about this problem, once I split it up at this point, I'm going to get q is equal to 11 over 7, and q is equal to negative 11 over 7, and I have no more algebra to perform. This is done. So I can write the solution to q as negative 11 over 7 and 11 over 7 in set notation, or as I have it expressed here. So a few of these questions do get more trickier. So I'm going to show you about 3 more of these before we go to the next part of the lesson for section 8.2. Let's take a look further at some more challenging problems. Here is question number 43. So we have here, sorry, not question 43. I'm actually looking at 45. So this is going to be 5 minus 2 times 3x minus 4, or the absolute value of 3x minus 4 is going to equal negative 5. Okay, so let's see what work is going to be involved in this before we go forward. So now, I need first to get rid of this positive 5, so I'm going to go ahead and I'm going to subtract 5 from both sides. 5 minus 5, that reduces to 0. Negative 5, that's going to give me negative 10. So now I'm going to have here negative 2 times 3x minus 4 is going to equal negative 10. Now I need to get rid of this negative 2, and because it's multiplying the absolute value of this, I'm going to go ahead and I'm going to divide both sides by negative 2, which will happen. That'll give me 3x minus 4, the absolute value of that, is going to equal 5. So I've already performed 2 steps to help simplify this without even splitting this up yet. But now that I have the absolute value by itself, I can now split this up and get the solution I need. So let's take a look at this now, and let's see what we do. So this is going to be 3x minus 4 is equal to 5. And then 3x minus 4 is equal to negative 5. So I'm just going to solve each of these and see what I get. So let me add 4 to both sides. That'll be 3x is equal to 9. Divide by 3, x equals 3. Over here, if I add 4, 3x equals negative 1. Here x will equal 1/3. So now, my 2 solutions to the original problem we started with are going to be x is equal to 3 and x is equal to negative 1/3. Or I write, using the set notation, as 1/3 and 3. So before we go to some of the more challenging questions in this, we're going to go ahead and take a look at one other type problem, which is kind of a more conceptual question, which can be tricky for some students. We're going to go to question number 30. And it's going to be the absolute value of 7x minus 2 equals negative 9. Here's the problem. I can't put anything into an absolute value that will ever generate a negative value. You might say, for example, if I put a negative 1 in there, negative 1 times 7 will be negative 7. negative 7 times 2 will be negative 9. And that will give you a negative 9 in the absolute value. But the absolute value of negative 9 is still 9. It will never give you a negative 9 on the outside. Because this is a problem that is not solvable, we say that we express the answer as this, which means two things. It means that there's no solution, but more specifically, we represent this as what we call the null or the empty set. So this represents a null or an empty set. There's nothing we can put in here that's going to generate a negative 9. So this answer here has no possible solution. So if you have questions about this, please feel free to ask me about that in class. Let's take a look at a few more daunting questions that you may run across here. So we have now 54. This is going to be the absolute value of 3x plus 2 is equal to the absolute value of x minus 6. So what we do when we have an absolute value on both sides is the following. We're going to go ahead and we're going to split this up in the following way. A little more space than normal because of the size of the question. We'll say that 3x plus 2 is going to equal x minus 6. And over here we're going to say 3x plus 2 is equal to the negation of this. But I'm going to put parentheses around this because I have to negate the entire thing. That's an important takeaway from this. So I need to rewrite this a little bit by distributing the negative, or basically changing the signs of everything in here. So this would be 3x plus 2 equals negative x plus 6. So I need to change the sign of both parts in here by distributing the negative. And now I can solve each part. So I'm going to go ahead and subtract x from both sides. That'll be 2x plus 2 is equal to negative 6. I'll subtract 2. So that'll be 2x is equal to negative 8. If I divide both sides by 2, I'll get x is equal to negative 4. Over here, I'm going to add x to both sides. That's going to be 4x plus 2 is equal to 6. Here I'm going to subtract 2. So it's going to be 4x is equal to 4. And now I divide by 4. X is going to equal 1. So now I have two solutions for this up here. And now I can go ahead and write this in set notation as negative 4 and 1. And these are my two solutions for problem number 54. We'll go ahead and take a look at one more for a little more reinforcement. And let's see what we come up with for this here. So one more question, a little more difficult, and we're going to wrap up this section of 8.2. This is going to be question number 61. And that's going to be the absolute value of 7 minus 4a is equal to the absolute value of 4a plus 5. If you want to, you may try this problem on your own and pause this, and then you can check your solution against my work here, or you can just keep watching and whatever your comfort is. So I'm going to write this as 7 minus 4a is equal to 4a plus 5. And I can write this here as 7 minus 4a equals the negation of this, negative 4a plus 5. Over here, I'm going to go ahead and, well, let's simplify this first. So I'm going to get 7 minus 4a is equal to negative 4a plus 5. And let's solve each of these now. Let me go ahead by adding 4a to both sides. So we get 7 equals 8a plus 5. And subtract 5 now from both sides. 7 minus 5 will be 2, so 2 will equal 8a. if I divide both sides by 8, a is going to equal 1 over 4. Over here, if I add 4a to both sides, what we find ourselves left with is something a little interesting, because we have 7 being equal now to 5, which is not possible. So for this one, there is basically no solution. However, we do have a solution for this one, and in that case, the solution is 1 over 4. So for this absolute value equation, we only have one solution that we can put in the set, and that's going to be 1/4. So I hope that this helps to clarify this procedure, and please feel free to bring your questions to class. The next lesson is going to cover absolute value inequalities.